problem. So in last class, we have done derivation of expression for kinetic energy. So how many of you learned the derivation? If you have seen the derivation, finally we have derived that. So the kinetic energy is equals to, what is the formula, guys? Half into mass into velocity square. So this is what the expression for, mathematical expression for kinetic energy. So before that, we studied types of potential energy also. So potential energy is two types. One is gravitational potential energy. Can you tell me what is the gravitational potential energy formula, please? Gravitational potential energy formula.
mgh.
Yes. So gravitational potential energy formula is mgh. And then we studied elastic potential energy. What is the formula of elastic potential energy? Anybody? Yes, please. Half into k into x square. So what do you mean by k? Spring constant, and x means elongation or compression of the spring. Am I right or wrong? Everybody? Yes, please. Either extension or compression of the spring. So that is what elastic potential energy. You dumb people, you get out from the meeting, no issues. So now kinetic energy derivation we studied last class. That is what half mv square. So I hope everybody understand how to derive the derivation for kinetic energy. You must need to solve in your classwork. I want to check it from today. Everybody's I will monitor. I will see. Alfin, are you taking the notebook notes or not? I'll check it. So today's class we are going to see work energy theorem. So what is this work energy theorem? Let us discuss now. So and then we'll go with the remaining concepts. So what is the relation between kinetic energy and movement or not? So work energy theorem. Work energy theorem. So what do you mean by work energy theorem? So first write the statement. Work done on a body, all of you write, work done on a body, work done on a body by a resultant force, acting on it is equal to the change in kinetic energy of the body. Okay, now keep it in mind, work energy theorem is only for kinetic energy. No, not for what? Not for potential energy.
Potential energy.
Theorem is only applicable for kinetic energy, not for potential energy. So that is also you have to remember. Okay. So from the statement, what is the statement they are saying here? The work done on a body by a resultant force on it is equal to the change in kinetic energy of the body. So from that I can say work done W is equals to, what I can say, guys? Work done is equals to, they are saying change in kinetic energy. So change means how we can represent. We all studied many times. Change means how we can represent delta kinetic energy. So that is only called as work energy theorem. So where the delta means change in kinetic energy, then actually it is equals to work energy theorem. For example, all of you observe how we can. So suppose there is a car who is traveling with the initial velocity 30 meter per second. How much it is? 30 meter per second. After traveling certain distance, the velocity of the car has been changed to, understanding, into, for example, 50 meter per second. So this is the final velocity, and this is what velocity, everybody? Please respond. Initial velocity. Now, if you want to increase your car velocity from 30 to 50, do you need to apply the force or not? That is what is my first question. Everybody, do we need to apply the force or not? Please respond. All of you?
Yes, sir.
Yes. So, yes, sir. Whatever the work done by that applied force, that is what the resultant force, which is equals to what? Which is equals to change in kinetic energy. So that's all it is they are saying. So what is the kinetic energy here? I'll calculate it. the kinetic energy here, initial kinetic energy is equals to half into m into u square. Initial velocity is u square. What is the final kinetic energy? Anybody can tell me? Final kinetic energy, half into m into final velocity square. Understanding? This is initial velocity, this is final velocity. So, whatever the change in kinetic energy, if you are noticing here, which is equals to work done by a body, work done on a body by due to the what? Resultant force, means the force which we applied to increase the speed from 30 to 50, which is equals to change in kinetic energy. That is only called as work energy theorem. So work energy theorem says that, all of you remember, the work done on a body due to the resultant force or applied force is equals to final kinetic energy minus initial kinetic energy. That is only change in kinetic energy. So what is the final kinetic energy formula, everybody? Final kinetic energy means, check it everybody, half
mv
square minus initial kinetic energy. What is the formula? Half mu square. Okay, so that is what. If you want, you can take half and m common outside. So that final velocity square minus initial velocity square. So that is what is only called as work energy theorem. So please write it. So work energy theorem is only present for what? Everybody. It is only present for kinetic energy. Not existed for potential energy. So please write it. All of you. Are you writing, Alfin?
Yes, sir.
Yeah, please make it. Any doubt, you can ask. Hasini Sudhakar, please make it.
Yes, sir.
Yeah. Any doubt, guys? Anybody can ask.
Sir, in subset you have written force, no, F, no, sir, it's
F that is final. F means final, kinetic energy. Okay.
Then you have written initial
I,
form also, sir.
yeah, I means initial, F means final. Okay.
Okay.
I means initial kinetic energy. F means final kinetic energy. Okay, wa? Lingesh? Is it clear? Nivedan?
Yes, sir.
Yeah. Please make sure completed it. If it is over, then I will proceed. Kavya, I will rename your name. You need to follow the same format. Check your name. I renamed it. Alfin completed. Sagamitrai. So work energy theorem means simply you remember single word. What do you mean by work energy theorem? Work done is equals to change in. Work done is equals to what?
Change in kinetic energy.
That's all. That is called as work energy theorem. Understanding, Mr. Gokul, Sam? That's what it is. Okay. Next, relation between kinetic energy and momentum. In a theorem, what is a momentum formula? Everybody? Momentum formula. That is what. Okay. So write it. Very important one. Relation between kinetic energy and momentum. Shall we start? Everybody? Yes, please. Relation between kinetic energy and momentum. Okay. So let us see that. We all people knows momentum formula. What is momentum formula? Symbol. What is a momentum symbol?
P.
Yeah, P. So momentum is equals to mass into velocity. Am I right or wrong? Yes. Mass into velocity. And let me take kinetic energy formula. So what is the kinetic energy? Anybody can tell? Kinetic energy, please. Kinetic energy equals to half mv square. Now, all of you observe very carefully. You all people tell me, can I write as a v square as a v into v? Any problem for anybody? Any problem for anybody? I will write 2 square as a 2 into 2. Any problem? Same way, v square I am writing as a v into v. Any problem? Please respond.
No, sir.
No. That's all it is. So half into, can I write it as a mv together? bracket I will put, nothing is there. So mv means what? We all knows that mv, mass into velocity, means what? Speak, guys.
Momentum.
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 That's all it is. So half into momentum into v. That's all. You can see that. So we can make it as a, everybody, what I can write it? Please respond.
Half into P.
Yes. So can I write it as a half into P into V? Am I right? Everybody? Yes, please.
Yes, sir.
From the first equation, can I write it as again? Momentum is equals to mass into velocity. From that, velocity is equals to what, guys? Girls? Velocity is equals to what? Speak loudly. Velocity is equals to what? Mass is in multiplication. Will come this side, what it will become? Nobody will answer. Division. Understanding? So in place of V, can I write it as a half into momentum into velocity, means momentum by mass. Am I right, guys? Which is equals to, can I write half into P square by M? Is it right, guys? Or else I can
Yes, sir.
write P square by 2M. So this is the relationship between momentum and kinetic energy. Please write it. Anybody having doubt, you can ask. The most important one. All of you. Do it quick. Any doubt? Please let me know. Purima? Nobody answering.
Understood, sir.
Yes, sir.
Just see, physics is like ulta pulta. You have to make this side, that side, this side, that's all. Nothing else is there. Just you have to make sure you have to concentrate. You should be able to understand what is happening. That's all it is. Clear? Any doubt? Anybody can ask. All of you understood, Amma?
Yes, sir.
Yeah. Completed means let me know. So what is the relationship between kinetic energy and momentum?
P square by 2.
P square by 2m. See, kinetic energy is 4th chapter of our school. Momentum is 2nd chapter of our school. So now 2nd chapter and 4th chapter integrated or not? So there is a relation you can find. So once you study the 4th chapter, they may be asked the question from the 1st chapter and they may be asked you to find the 4th chapter also. Okay. So now you can see, we can form your questions. You can find it in the worksheet. They will give you the kinetic energy and they may be asked you to find the momentum. Will you all people able to find it or not? Everybody? So we all knows that kinetic energy is equals to P square by 2m. We want P now. So P square is equals to 2 into m into kinetic energy. Okay. Now P is equals to what? Root over 2 into m into kinetic energy. Do you all understanding, everybody? Yes, please. So like this, they may be integrated.
Yes, sir.
They can ask you. So please remember that. So whatever the way they ask, you must able to solve. That is what is very important. I hope everybody understand this. What is the relationship between kinetic energy and momentum? All of you clear? Yes?
Yes, sir.
Yeah.
Yes,
So that's
sir.
all it is. Now, let us go with that. This is what about these things. Now we are going to prove a concept called as the most important one, which is what? Law of conservation of energy. So you might be studied even chemistry 2nd chapter. Already is over, I think. So can you tell me
Yes,
what
sir.
is law of conservation of mass? You might be studied there, or law of conservation of energy.
Uh,
Same.
Mass of solute by mass of.
No. What are you speaking? I am asking definition of law of conservation of mass. 2nd chapter you study. Law of conservation of mass. 2nd chapter in chemistry. Law of conservation of mass. Please respond. Law of conservation of mass. Instead of mass, I am using a concept called as energy. I think you not studied till now. Huh?
No, sir.
Sir,
Wait. Law of conservation.
mass of solute.
No, mass of solute, not a mass. Law of conservation of energy, mass, you will get it in chemistry only. I think 3rd chapter. 3rd chapter. Third chapter. Okay.
It has
Nothing.
mass of solute present in the solution, sir.
That is not called as a law of conservation of mass. Mass conservation of mass means What is that? Before reaction and after reaction, the amount of products and reactants is remains same. That is what?
Sir, that is the concentration, sir. She is confusing it.
Yeah. Don't get confused.
Concentration.
Okay. Law of conservation of energy means, all of you remember, energy neither be created nor be destroyed. So that is what. So let us write the statement. I think chemistry you will get it in second chapter, third chapter. So I don't know the exactly. So if you're having a book, you can check it. Everything. Third chapter, I think it will come. Yes, it is. It will come in the third chapter. So you'll study that. So law of conservation of energy, law of conservation of momentum. Like momentum we studied. What is momentum? Law of conservation of momentum. Everybody. Momentum before collision is equals to what? Yes, please. Momentum before collision is equals to momentum after collision. Means it is remains conserved. Remains conserved. That is only called as law of conservation of momentum. Momentum neither be created nor be destroyed. Momentum neither be created nor be destroyed, but it will be transferred from one body to another body. So that is only we is to called as law of conservation of momentum. That's what we say. We have proved it mathematically. Momentum before collision is equals to what, everybody? Momentum
After
After
collision.
after
collision.
collision. Same way, the law of conservation of energy will says that, all of you write, energy neither be created nor be destroyed. Energy can neither be created nor destroyed, neither be created nor be destroyed, but
Then it is already present in it, sir.
yes, it's already existed, but it can be converted from one form to another. But it can be converted. Now, whatever the energy we are using, it is a converted energy, Mari. It is not created energy and it is not destroyed energy. Some form of energy is converting into another form. That's all it is.
Yes, sir.
Yeah, can be converted from one form to another. So this is only called as what? Everybody. Conservation of energy. Understanding? And this is the one of the fundamental law of nature. One of the fundamental, basic fundamental law of nature. Fundamental laws of nature it is.
Sir, is it one of the
One of the fundamental laws of nature, means law of conservation of energy. We will get law of conservation of mass, law of conservation of momentum. All the statements will say the same. If I replace energy with the mass, law of conservation of mass. If I replace energy with the momentum, law of conservation of momentum. So nobody can create the momentum, nobody can destroy the momentum. Momentum is always remains conserved before collision and after collision. Mass of the body is always remains constant before reaction and after reaction. So that is what is like energy neither be created nor be destroyed. So only it can be converted from one form of energy into another form of energy. Do you all understand, everybody? Yes, please. All of you, please respond. Now, before going to verification, please all of you keep reading verification of the law of conservation of energy in the case of freely falling body. In the case of freely falling body. Shall we start, everybody? So now before going to start this one, so first of all, you should understand from the chapter 1 and all, if any object is falling freely, so we all knows that initial velocity is what? Speak loudly. Body is falling
Zero.
freely. Initial velocity is what? Everybody, 0.
Zero.
Before touching, it is having what? Speak loudly. Final
Maximum
velocity.
velocity.
Maximum. Okay. Now, If you notice it here, now let us talk about the potential energy. Of course, it is moving downwards, so that G value is positive or negative? Positive. You all remember, correct? Now, next. Now, you tell me, what do you mean by kinetic energy? Kinetic energy is possessed by the body only due to the what? Due to the motion. Understanding all of you? Now, potential energy is possessed. It is which potential energy, guys? Free fall means which potential energy? Gravitational.
Gravity.
Please respond.
Potential energy.
Gravitational potential energy. It is free fall. So now you tell me, gravitational potential energy means it is due to the what? State of position. Due to the
Position.
position. State means compressed or elongated. Or that is,
Elastic.
yes, elastic potential energy is due to the state. Position, due to the position, the potential energy possessed by the body is called as what energy? Gravitational potential energy. Understanding? So now, I already taught you people, if the body comes to the ground, what is the potential energy? Ground, baseline. It is a ground, guys.
Zero.
Zero. If it is in the ground, what is the potential energy? Everybody. Gravitational potential energy is equals to zero. Because the position above from the ground, so there is no height. What is the potential energy formula? Gravitational potential energy, mgh. So h becomes zero, so that entire gravitational potential energy becomes zero when a body comes to the rest. Am I right or wrong? At the surface. Clear, everybody? Yes, all of you. So now, if you remember this, then we can go with the verification of the law of conservation of energy in the case of freely falling body. Of course, other cases also there. So let us verify in this case alone. Shall we start, guys? Everybody, are you ready? Very most important one. See, theoretically, I can teach you this concept very easily, but I want to make it mathematically only so that it will be helpful for your future also. So this is what freely falling case. All of you observe. So I'm going to show you freely falling body. Two cases it is stated. So a body is dropped from a point A, and when it is in middle, and when it is reached to the ground. So totally, we have to find either energy is conserved or not. Shall we start, everyone? Everybody? Yes, please.
Yes, sir.
Yeah. So
Yes.
if you understand this, this is enough for us. Okay. Now, just 1 second. I just need to have water. I am feeling very dry throat. Okay. Just have a glass. Draw this picture, everybody. By this time, I'll finish it. Draw the picture. So we'll start, everybody. Yes, please. If you are okay, we'll start.
Yes,
Hello?
sir.
1 minute, sir.
Yeah. Please make sure you have to draw this diagram before going to start. Okay. Now consider a body of mass m at rest at a certain height. At rest. Now this body is at what? Above from the ground. And it's what is the velocity? It's at rest. Rest in the sense of its velocity is what? We all people knows. Rest means initial velocity is what? Zero. See, it is above from the ground. That's all. It is not ready to fall. Once it will fall, only it will possess kinetic energy. When it is above from the ground, it is initial velocity is zero. Will you all agree with me? Yes? Please respond. So,
Yes, sir.
at point A, if you notice it, the point A, that the total energy of the body at point A is equal to its potential energy. Now, Y means always no, mechanical energy means sum of the two energies. Anybody can tell me what is the mechanical energy? Please respond. Mechanical energy means what, guys? Sum of the two energies. What is that?
Potential energy, kinetic energy.
Potential energy plus kinetic energy. Now, at the point A alone, you tell me, it is only above from the ground. So means in the sense of its initial velocity is zero. So that kinetic energy become what? Kinetic energy at a point A, which is equals to what? Half mv square. So velocity is 0. So that total kinetic energy is what? Speed graph 0.
0.
Okay, at point A, you want, you can write it very clearly. So kinetic energy at point A is 0. So it is above from the ground. So that only what energy it will be possessed, everybody? What energy it will be
Poten-
possessed?
Potential energy.
Potential energy. And the total height is what? Total height is h. Total height is h. And the till this B point is x. Means from A to B, what is the remaining distance? A to B remaining distance is how much, guys? See, from here to here, the
Minus
total height is h. And till here, we'll consider as a x, means remaining distance is what? H minus x. Am I right or wrong?
Yes, sir.
Yes, please. So at the
Yes,
point A, total height is h. So what is the potential energy? mgh. Is it okay, guys? Speak, guys, at point A. Now,
yes, sir.
what is the total energy at point A? What is the total energy? Mechanical energy at point A. Write it. Total energy at A, which is equals to, that is what mechanical energy. So total energy at A is equals to two energies, potential energy plus kinetic energy. So we all know that kinetic energy becomes 0. So potential energy mgh plus 0. So which is equals to what is the total energy, guys? Speak loudly. At point A, what is the total energy? Point A total energy is equals to potential energy. Am I right or wrong, guys? Nobody answering. Am I clear?
Yes, sir.
Yes, all of you? Respond, Ra.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
All of you
Yes, sir.
observe very carefully. At point B, body comes to what point now? It comes from point A to point A to
Point B.
point B.
Point
Now
B.
observe very carefully. At point B, it is above from the ground with what height? Above from the ground with what height? That is what I wanted.
With X
Above
height.
from the ground.
X
What
meter.
height? Speak loudly.
meter.
X meters. So means in a sense of potential energy at point B, which is equals to mgx. Is it okay? Mr. Nivedan, will you agree with me? All of you?
Yes, sir.
Yes.
Yes, sir.
Sir, I can understand, sir.
At point B, always from the ground we have to see. From the ground, what is the elevation? Shivani, from the ground at B point, body is at what height? X meters. Correct? Before it is at H meters, so that potential energy is mgh. Now at what height it is? X meters height. Understanding? So it's already traveled certain distance and it came to the X meters above from the ground. So potential energy at B point is mgx. Is it okay? Clear?
Yes, sir.
Yes. Now observe very carefully. Now, if X is the height of the position B, X is the height of the position B from the ground, what is the displacement of the body? From A to B, what is the displacement? Check it, everybody. I want to know. What is the displacement of the body from A to B? What is the displacement of the body from A to B? Everybody.
H minus
X
X.
minus X.
H minus X. H minus X is the displacement of the body. Is it okay, guys? Everybody? All of you?
That's
A
what point
body-
A as H minus X.
H minus body travel a distance of A to B. How much, Mari? How much distance it is travel? H minus X only. Am I
H
right?
minus X.
All of you understood, Amma? Please respond. Now,
Sir.
then at B point, definitely body is having some velocity. Am I right or wrong? If the body is freely falling, initial velocity is 0. Middle somewhere velocity will attain. Before touching the ground, velocity is maximum. That is what we studied. Am I right or wrong? Everybody.
Yes, sir.
Yes, sir.
Yes, sir.
Now, if you want to
Yes,
find
sir.
at this point, I want to find the kinetic energy. Then you
X
need to know
minus H minus X.
V square.
Half into V
Yeah,
point.
V square. But we don't know the V. Am I right or wrong? What is that V? We don't know. So how to find the V? I know the displacement. I know the acceleration. So can you find the G? Anybody can tell? Which equation we have to use it? Initial velocity is 0. And we want to find at this point velocity. So what is the equation? We can use it. Distance also we know. S equals to H minus X. Please respond. Which equation? Yes.
Second equation.
Second equation. Time I am not at all mentioned. V is the... Yes,
Sir,
please.
last equations.
V is the
Third.
velocity of the body. Velocity of the body at point B. Body at B. So which equation will use, Agalya? V
Third.
square minus U square is equals to 2GH.
2A.
2AS or 2GH. So initial velocity is 0. Final velocity V square is equals to 2 into G into H value is how much? H value, check it everybody. H
Yes.
minus X.
H minus X.
H minus X. Now, can I need to send the V square to that side? Not required, because our formula, what we have? V are V square.
E
Yes,
square.
respond.
V
V
square.
square. So directly I can substitute 2G into H minus X. Is it okay, guys? All of you understand? Nobody will respond. Respond, guys.
Yes, sir.
Yes,
Yes,
that's
sir.
all.
Yes,
So
sir.
then kinetic energy, I will substitute it directly. So kinetic energy at B point, which is equals to half into M into, in place of V square, what I can write? Everybody. Check it, everybody.
2G into H minus X.
Into H minus X. Will you all agree with me? All of you?
Yes, sir.
Yes?
Yes,
So
Yes,
now
sir.
something will
Yes,
get
sir.
cancelled. What is it
Cancel.
cancelled? 2 will get cancelled.
Cancel.
Remaining. All of you check it. Can I get it like a MGH minus MGX? Will you all agree with me? Please.
Yes, sir.
Yes? Nobody is answering. What I should say?
Yes, sir.
Sir, no, sir.
Yes, sir.
How, sir? Check it, ra. 2 will get cancelled. M into G, MG. So MG into H, MGH. M into G, MG. MG into X, MGX. Correct? Innara? Sir, okay, you want
Yes,
more
sir.
simplified? Do you understand or not this one? Can I write more simplified? If you want, I'll write it.
No.
Okay, I'll write
No.
it. Let it be. Let everybody should understand. So 1 by 2.
I have one doubt, sir.
Yeah.
First of all, you are finding the height only, no, sir.
I am finding height what, Mari? What is the distance travel from A to B? I am finding the velocity at point B. Velocity at point B. If I want to find the kinetic energy, I need to know the velocity at point B. That's all.
Yes, sir.
So velocity means what? The distance traveled by the body. And initial velocity is 0. And final velocity. For example, can you tell me what is the velocity at point C means? How to find before touching the ground? It is already traveled. What is the displacement? Anybody can tell? What is the total displacement traveled by the body? Which is equals to?
X meter.
X meters or H meters or?
H meters.
H meters.
X meter.
Understand, Mr. Nivedan?
Yes.
Yes, till point B it is traveled only yes, H minus X meters. Till point C means how much distance it is traveled, guys? Yes. Till C means how much distance it is traveled, H meters. Am I right or wrong? Everybody.
Yes, sir.
Yes.
Yes,
Now total total energy at point B is equals to kinetic energy plus potential energy. So that's all. You add it. So what is the answer here? 2 will get cancelled. So which will turns into MGH minus MGX. So I will substitute it. MGH minus MGX plus what is the potential energy? Check it. At point B, what is the potential energy? Yes, please. All of you. MGX. Okay. So plus MGX and minus MGX will get cancelled. What is the remains energy? Total potential, total energy at point B, which is equals to also what? MGH. Okay. Now, those who are having doubt, you remember wherever you are finding the potential energy, you should need to know what is the elevation from the ground. Keep it in mind, if you want to calculate the potential energy at any point, you need to know from the ground what is the height. From the ground, what is the height? That is, you should remember. If you want to know kinetic energy, you need to know only one thing. Velocity at that particular point. Velocity at that particular point. Is it okay, guys? Agale understand? Kavya?
Sir, how did you get that 1/2 meters, sir?
Which one, Mari? Mari, 1/2 meters not Mari. 1/2 m ra Mari. Formula ra half mv square. In place of v square, I am substituting 2g into h minus x. Meter
Yes, sir.
mass. You are forgetting the basic thing. For basic formula, what is the kinetic energy formula? Half mv square. Understand? At point B, what is the velocity I am finding? At point B, what is the velocity? I found it as a 2g into h minus x. Understanding?
Yes, sir.
Then that I substituted in the kinetic energy formula, so that I got it kinetic energy at point B is equals to mgh minus mgx. Clear?
Yes, sir.
Yeah. Anybody having doubt? Please respond. All of you understood, Amma?
Yes, sir.
Yeah. Lingesh, h minus x is the height from A to B. That is the displacement traveled. If I drop one body from, for example, see, total height is 10 meters, Mr. Lingesh. It came to this point. Now I will say here, from the ground, it is at 7 meters. Then what is the remaining distance it is traveled from A to B? Can you tell me? How much it is? 10 minus 7, which is equals to 3 meters. Am I right or wrong?
Yes, sir.
That is a displacement traveled from A to B. That's all. Do you understand, Ra? Okay.
Yes, sir.
Yeah. Now, from A to C, at point C, we are calculating. From A to C means what is the displacement traveled by the body? Anybody can tell? Next, one more question came. Abhirami having doubts, sir. Potential energy means mgh. Only no, sir. Of course, girl, I am saying mgh only, but h means what? Height from the ground. Height from the ground. Height from the ground at B point is how much? What is the height from the ground, Ra? Everybody? What is the height from the ground at B point?
Yes.
X
X.
minus.
So mgh is equals to, h is equals to x